All right, we're going to work through problem number 1 on this function characteristics worksheet. And remember, what we're trying to do is just to kind of pick apart some of the features of a given graph, right? So number 1 is this 1 over the square root of 36 minus x squared. And the first thing you want to do is you want to be able to graph it. And we'll use Desmos, right, since you're already on a computer. So open up your web browser, whatever it might be, minus Chrome. Type in desmos.com and you should get to this window. Remember, if I go too fast, right, you can always hit pause. And if I'm too slow, I guess you can hit fast forward. All right, I'm going to hit graphing calculator, and this is the window that comes up. And here you could just type in the function as you see it. All the keys you need are at the bottom of the screen. So I type my y equals, and then I need a fraction. A fraction is just a division problem, so it's just 1 divided by. Hit the division key, and you'll get that fraction bar. And the square root button is right at the bottom of the keyboard. Square root, and I'm going to type 36 minus x to the second, and I get this graph. It looks kind of like a parabola, except very sharp. So I'm going to take that, and I've already kind of put it into the worksheet here just below. Actually, on page 2 of the worksheet. That way I'll have something I can write on myself. First thing I want you to notice when you have a computer-generated sheet is they kind of just end graphs arbitrarily. And graphs don't do that. Graphs, for the most part, keep going. There's no reason for them to stop. So we put arrows on when we actually draw them on our paper, meaning, hey, that graph just keeps going up and up and up and up. The second thing that might not be obvious, depending on how well you're zoomed in, but this graph it looks like it gets to 0 in the y value, but it doesn't quite get there. It's just a little bit above 0, and you can see it's perfectly symmetric in the y-axis. The reason it's symmetric is it's like an x squared function, right? So whether you put in positives or negatives, you get the same y values back. All right, so let's write down some of the characteristics. Whenever we have a function, the first thing we talk about is the domain and range. So if you look at the domain, those are the x values. The first thing you should notice is, hey, something's going on at -6 and +6. And why are those the key values? Because if you put 6 or -6 into this function, you're going to get 1 over 0, which is, of course, undefined, right? And, of course, when you have an undefined, generally you get something goofy in the graph. In this case, you actually get vertical asymptotes, right? So, I'll change colors here. Maybe I'll make them blue, right? But at 6 and at -6, you get this vertical asymptote. And those are just guidelines, right? It's like the graph gets really, really close to those values, but never quite gets there. But that's what kind of drives your domain, right? So the domain are all the x values between -6 and 6, and in interval notation, I put those in parentheses because I never quite get to those values, right? -6 does not work in the function. The range is how high and how low you go, right? And of course, we said you don't quite get to y equals 0. You get just above, you get to this ordered pair right here, which of course is 0 comma something. And how do you get a y value if you have an x value? Plug it in, right? So if I come down here and I let x become 0, right? If I plug in 0 for x, I get 1 over square root of 36 minus 0, which is 1/6. And if if you're on Desmos and you zoom in there, you'll see the y value is really close to 1/6, which is about 0.16 repeating as a decimal. So the y values get as low as 1/6, then they go all the way up. So we write infinity for the high point. And since we actually hit the ordered pair 0, 1/6, 1/6 is included, right? You can get, if you plug in 0 for x, you can get 1/6. The next thing we talk about with functions is whether they're increasing or decreasing. And I'm going to color code this one. Over here, this function, as you move left to right, is going uphill. So that's increasing, right? We say the function is increasing on the interval 0 to 6, right? So in other words, in this interval from 0 through 6, my graph is going uphill. Right? Notice those are x values. We talk about increasing and decreasing in terms of x values. And let's go, what should we go with? Pink over here? Yeah, why not? This part of the graph, if you look, even though the arrow's going up, as you move left to right, the function is going downhill. So that would be a decreasing interval from -6 to 0. You're right. The order matters. We go low to high. So you don't say 0 to -6, you say -6 to 0. Maybe I'll copy that up here, right? We'll say it's decreasing from the interval from -6 to 0. And we're increasing from 0 to +6. Okay? What else can we talk about in this graph? Let's talk about the symmetry. It's symmetric in the y-axis, right? And that implies that you have an even function. Any graph that's symmetric in the y-axis is even. Is it a continuous function? Yes, it is. There are no breaks. Oops. Is it a one-to-one function? No. It fails the horizontal line test, right? How do we show that? I don't know. Take a horizontal line here, we cut it in 2 spots. So it's not one-to-one. Finally, are there any intercepts or, well, there's no x-intercept. So there's no zeros. And of course, do we have a y-intercept? Yeah, we do, right? 0, 1/6. So those are just a few of the features we can list for that function.